Okay, so here I have drawn two disks or cylinders that have the same moment of inertia, I star, about their centers, and they're rotating about some central axis that goes through the center. There's a hole here and there's no friction here, so they can rotate freely. This one rotates at counterclockwise angular speed omega naught, and this one at 3 omega naught clockwise, and then they come together. Friction brings them to a common angular speed. Let's find what that is. And what we want to recognize is that there is these are internal torques that act between these two objects, and so there's no net torque about this axis or about the centers of these disks or cylinders, and so torque is zero about this point, and therefore L initial equals L final in magnitude. And so we want to build this, and this will come from that principle. So the initial angular momentum is, this one has angular momentum, it's I times omega naught, that's actually I star, plus the angular momentum of this one, but different direction of rotation. So we have an I star times a minus 3 omega naught. So the negative is in the clockwise direction. And then we have the final moment of inertia, which is twice I star, and the final angular speed. And so this side becomes, right, it's 1 times this quantity minus 3 times that quantity. So we get minus 2 I star omega naught, and that's equal to 2 I star omega final. And so omega final is just equal to minus omega naught. And so the disks are rotating in the direction which is clockwise, because we made that clockwise direction to be negative, and so the final angular speed is omega naught in the clockwise direction. And if we want to look at the kinetic energy, the final kinetic energy, it's 1/2 times 2 I star for the moment of inertia times omega naught squared, which is just I star omega naught squared. Let's compare that to the initial kinetic energy, which is 1/2 I star omega naught squared plus 1/2 I star times 3 omega naught squared. And so that is I star omega naught squared over 2 plus, this is 9 I star omega naught squared over 2, and that is 10 over 2, which is 5 I star omega naught squared. And so clearly K final over K initial is less than 1. We have this divided by this, which is 1/5 of the energy is left as a result of this collision.